We are asked to find the gradient of the tangent to this curve at this point. And we cannot possibly imagine what this looks like. You can't even graph it on the calculator because you have the y within the x's. There is no way to factor this out. So what I'm going to do is I'm going to just draw a simplified drawing of just some trigonometric function that will help us figure out what it is we need. A gradient of the tangent to this curve. So let's imagine that point pi is going to be somewhere here, so that this is pi. This is very tiny, but okay, pi. And so at this particular point on the curve, there is a tangent, right? A tangent comes from Latin, it means touching. Is touching the curve, this curve, at this point, and it has the exact same gradient, the tangent has the exact same gradient as does the curve at this point. Now that is a hint to us, because it means that all we need to do is find the gradient function of this curve, which we're going to do by differentiating it implicitly, obviously, because the y's are within the x's. And then when you plug in this point into the gradient function, you're going to get the gradient of this curve at this point, which is going to be equivalent to the gradient of the tangent. So let's get to it. Let's differentiate this implicitly. X squared obviously is just 2x, and sine y is going to be dy dx, which is what you always have to put in when you use implicit differentiation and you're dealing with the y. And then simply differentiate it into cosine y, right? And then we have minus y, which is our derivative of the first times second. And then we go plus second, oh, I've done that already, plus first times derivative of the second, and derivative of y is dy dx. Let's not forget the minus. I'll just stick it in here, it's easier. And the derivative of 0 is 0. What we do next is we need to clean this up. There are actually two ways you can do this. You can either isolate dy dx on the left side of the equation first, and then plug in pi into x and pi into y, or you can just start plugging in right away, which I find a lot easier, and that's what I'm going to do now. And it's particularly easy in this case because the point is pi, so there isn't really a lot of thinking, just plug it in. 2 pi plus dy dx we have to keep the same. Cosine pi, notice that these are going to start falling out very nicely. Minus pi times dy dx is equal to 0. Next, we need to make dy dx the subject of this equation, or as I said earlier, put it to the left. So dy dx cosine pi, right, that's just this term, minus dy dx pi is equal to, and now I'm putting the constants on the other side, and that 2 pi minus pi is obviously pi, and so don't get confused with this is being multiplied. My hand is quite far away from the paper, so I can't write as nicely as I usually do. And then 2 pi minus pi will give us pi, and when you swing that over to the other side you get minus pi. Now from this we factor cosine pi, or I should say we factor dy dx, to get dy dx times cosine pi minus pi, and then when you divide both sides by cosine pi minus pi, you get dy dx minus pi over cosine pi minus pi. Now obviously cosine of pi is minus 1, and so you can rewrite this as minus pi over minus 1 minus pi Or if you factor out a minus 1 from the numerator and the denominator, and then just get rid of it, it's pi over 1 plus pi. You can also rationalize this further, but it isn't necessary. And this here is the gradient of the tangent to this curve at this particular point. And then if you were to take this further and you ask yourself, okay, what is the tangent? Then you would know that the tangent, the equation of the tangent, is y is equal to this, for our gradient, pi over 1 plus pi times x plus some constant b. And this constant b, if you remember the standard form of any equation, so this is y, x, this is the gradient, and this is the y-intercept. So this constant b will in fact tell us what this y-intercept of the function, of the tangent is. Now remember, this isn't actually our curve. I've just simplified it so that I can draw something, because I can't even figure out what this is on the calculator, and it really isn't necessary. You don't need to know what it looks like. And if you were to then want to find the equation of the tangent, what you would have to do is you would then put this point in pi, the y and the x, and or I should say put it in here, pi, and then when you work this out a little bit here and there, you would get b. But we're not asked to do that. I've just extended this freely. So in fact, this is our answer. That is the gradient of the tangent.